Okay, so here we have an exponential equation. We know that it is an exponential equation because of the exponent having a variable. We want to solve for that variable. The first thing that we have to attempt to do is get the same bases. Notice we have a base of 3 and a base of 81. Not the same. However, we can change 81 to a base of 3. That would be 3 to the 4th power. And so now we have 3 to the x plus 1 equals 3 to the 4th power. Since we have the same bases, the exponents must be equal. So our next step is to write this as x plus 1 equals 4. Now we solve for x, subtract 1 from both sides, so x equals 3. Remember, you should always check your work, and we should be able to easily see that 3 raised to the 3 plus 1 should equal 81. We're asking ourselves if it is equal in fact. This becomes 3 to the 4th power, which is 81, and that works out. Now we're going to move and look at a little more difficult equation. This equation involves the natural number e, and it will require us to use our properties of exponents, We have some of the same bases, but here's where our problem lies. We have a multiplication symbol on the right side. We have a power raised to a power. And we also have e in the denominator of a fraction. So we need to rewrite this right side of the equation in order to make it work. So the left side of the equation is going to stay just like it is, equal to, here, if we remember our properties of exponents, powers to powers means that we multiply. So this simply becomes e to the 2x times, and in order to get this to work well, we want to take this out of the denominator. So when we move it up, this becomes e to the negative 3. Now, the next property of exponents we're going to use is that when we multiply powers with the same base, we simply add their exponents. So in our next step, this is going to be e to the negative x squared equals e to 2x minus 3. I did say add. When we add a negative, it's the same thing as subtraction. Now again, here we are with the same bases, so the exponents have to be equal. And now we have an equation we can solve. We should notice that this is a quadratic equation, so I will get one side equal to 0 and solve it hopefully by factoring, but if not, then I may need to use some other method. If I look, I should be able to factor this. Negative 3 has factors of positive 3 and negative 1, so this is x plus 3 times x minus 1. And we set each one of these factors equal to 0 using the zero product property. X equals negative 3 and x equals 1. Now, let's look at a more real-world problem. Between 9 p.m. and 10 p.m., cars arrive at Burger King's drive-thru at a rate of 12 cars per hour, or 0.2 cars per minute. The following formula from the field of probability can be used to determine the probability that a car will arrive within t minutes of 9 p.m. The function of time is equal to 1 minus e to the negative 0.2t. Now, let me try to get rid of something in here. Of course, it's not going to go away. Let me try one more thing here. I don't know what this, oops. And let's see if we can get that out of here. Alright, let's come back here. Alright, so this is our function. We notice that we're subtracting our exponential portion of the equation from 1. We also notice that the exponential portion up here is negative, which lets me know that this could be represented in other terms as a fraction. Let's go ahead and look at the problem here. Determine the probability that a car will arrive within 5 minutes of 9 p.m. Well, if we go back to the problem, this function gives us exactly that. All we have to do is evaluate the function at 5. So that's what I'm going to do now. The function evaluated at 5 is equal to 1 minus e to the negative 0.2 times 5. Now the best thing to do in this situation, especially since e is an irrational number, is to use our calculator to type this in. Clear that. Okay, so this is going to be 1 minus e, which is going to be second in the natural log button, and this is going to be negative okay, let's try to clear this off. Okay, we need the e, negative 0.2 times 5. Okay, and now we can hit enter, and that would be our function value. Let me bring that back up real quick. 6.632, so let's say 0.63, which is 63%. It's a 63% probability. It's pretty high. Alright, let's look at the next one. Determine the probability that a car will arrive within 30 minutes of 9 p.m. Go back to the calculator, and I don't want to retype all of that, especially with the trouble the calculator seems to be giving me. So I'm going to do second, enter, and it brings up the same function that I just typed in, and I'm going to arrow over and change that 5 to a 30. And close the parentheses, press enter, and notice that it is 0.997. And I'm not going to round it up. I'm going to write it out as 0.9975. So the answer here is 0.9975, which is 99.75% probability. And be sure to use this information wisely, and if you have any questions, please let me know. Remember, you can always find me at mathmandy@yahoo.com. Have a good night.